take a look at analyzing the rational function. We've got r of x equals 3x squared minus 3x on top, and x squared plus x minus 12 on the bottom. The first thing we want to do is go ahead and factor the numerator and the denominator. So on top, we're going to notice that each term has a 3x in common that we can go ahead and take out. It's going to leave us with an x minus 1 inside our parentheses. And in our denominator, we're going to factor this into x plus 4 and x minus 3. Now that we have it factored, you'll notice that none of the terms match up there, so there's nothing we can cancel, so our function is in lowest terms. So let's go ahead and take a look at our domain. One of the first things we want to do is find our vertical asymptotes. So keep in mind that that's going to be when our denominator is equal to 0. So let's go ahead and take each set of parentheses. We'll set that equal to 0. So we've got x plus 4 is equal to 0, and x minus 3 is equal to 0. And if we subtract 4 from both sides here, we're going to get an x value of negative 4. And we can add 3 to both sides of this equation, and we'll get an x value of positive 3. So we have two vertical asymptotes here. X equals negative 4, and x equals 3. So when we're working with our domain, it can be any other x value except those two values. Alright, so let's go ahead and give ourselves a little sketch here of our x-axis. So at an x value of negative 4 and an x value of 3, these are going to be vertical asymptotes. I'm going to go ahead and put VA under each one of those. Right, so that kind of divides our graph into 3 intervals. I'm going to call this interval A, interval B, and interval C. And that's where our graph is going to lie. So those are the values we're allowed to use in our domain. So our first interval here is going to be from negative infinity to negative 4. We'll go ahead and put a parenthesis on that 4 since that's where we have an asymptote. Our middle interval, which is interval B, is going to go from negative 4 to 3. And then our last interval, which is where you see the C, is going to go from 3 to positive infinity. For the next part, we want to go ahead and find the x and y intercepts of our graph. Remember that when you're finding the x-intercepts, that's the same thing as plugging in 0 for your y value. And when you're finding the y-intercepts, that's the same thing as plugging in an x value of 0. Let's go ahead and start by finding our y-intercept. We're going to be calculating r of 0, and we'll plug in 0 each time we see an x value in our function. So we've got 3 times 0 squared, minus 3 times 0. And in our denominator, we've got 0 squared plus 0 minus 12. And we can go ahead and simplify what we've got in both our numerator and our denominator. 0 squared times 3 is going to give us 0, and 3 times 0 is going to give us 0. So we're going to end up with a 0 on top, and in our denominator, we're going to end up with a negative 12. So this will come out to be a 0. And our question here says to write these as ordered pairs, so for our y-intercept, our x value was 0, and the y value was 0. Let's go ahead and do our x-intercept next. We want to go ahead and plug in the 0 for the y value. That's the same thing as saying r of x is equal to 0. So we're going to set our entire function equal to 0. And it doesn't matter if you use the original function there or if you want to use the factored form of it. You can do either one of those. I'm going to go ahead and use the factored form on this one. And remember that the only way you can have a fraction be equal to 0 is if you had 0 on the top of your fraction. It doesn't matter what number you have on the bottom, right? But that's when your fraction would be equal to 0. So the only part we're really concerned about here is the top. So let's go ahead and set the top equal to 0. So that means I've got 3x times x minus 1 equal to 0. And the only time this could happen is if my 3x is equal to 0, or if my x minus 1 piece is equal to 0. Okay, so we can solve each of these equations for x. On this one on the left, if we divide both sides here by 3, we're going to get an x value of 0. And for our second equation, we're going to get an x value of 1. So we have two x-intercepts here. Our first one is the point 0, 0, and our second one is the point 1, 0. Now we want to locate any horizontal or oblique asymptotes. We want to determine which type it has, if any of them, and in this case I'm going to go ahead and use my original function, the one where it was not factored. Alright, so let's take a look at our numerator. You'll notice that this has a degree of 2 on top. And in our denominator, our highest exponent down there is also a 2. So we have degree 2 on the bottom. So this is the case where we have the same degree, top and bottom. So this is an example of case 2. And remember, in this case 2 example, you want to go ahead and use your leading terms. To help you get your asymptotes. It's automatically going to have a horizontal asymptote. Okay, so I've got y equals, my leading term on top is the 3x squared, and my leading term on the bottom is x squared. If we go ahead and reduce this, these x squareds are going to cancel, and that's going to give us an equation of y equals 3 as our horizontal asymptote. And now we want to take all of our information and put it together so that we can graph our function. My recommendation here would be to go ahead and graph your asymptotes first, and then you can fill in your graph around those pieces. Okay, so remember from the previous slides we had vertical asymptote at x equals -4, and we had another one at x equals 3. We'll draw those as dotted lines. We have a horizontal asymptote at y equals 3. And once we get those graphed, then we can go ahead and put our function on the grid. So if we take a look at the graph on the right-hand side, right, we can see our asymptotes here at -4 and +3 for the x values. We can see the horizontal one at y equals 3. And then I went ahead and put our intercepts on the graph. Right, we've got the point 0, 0, which was both an x and y intercept, and we have the point 1, 0, which was our second x-intercept. And you'll see that the graph here is in 3 different pieces. It's graphed in blue. Right, we have this portion in this upper left-hand quadrant. We have a portion in the right-hand quadrant over here, and then we have this piece in the middle between our x values of -4 and +3. And this is a good example of a graph if we're taking a look at the asymptotes. Notice your graph is never going to cross the vertical asymptotes, but it is allowed to cross a horizontal one, and you might see that happen on occasion. On this graph, you'll notice that it does pass through that 0.63, so it is crossing the horizontal asymptote in this case.